All right, so the instructions here, let's let that load up. It says to evaluate the six trigonometric functions of theta. Okay. Now, one of the things that I'm not sure if you've seen yet, but there's a reference triangle in every quadrant. So in quadrant 1, this is the reference triangle. And notice that the angle is made with the x-axis. In quadrant 2, this is the reference triangle. Quadrant 3, it looks like this. Quadrant 4, it looks like this. And this will matter later in the course. So in the spirit of prom, I would call this the reference bow tie. You can see a nice little shape like that. But what you need to do is, based on which quadrant it is, you want to draw that triangle. Okay, because it's really like you could draw this triangle here, but that is not the correct one to draw. You want to draw it with the x-axis always. And
Yeah.
that comes into play later in the course. So what I would have you do is make a little crosshairs here and just draw, rough drawing here. 5 minus 12. So 5 is the x, minus 12 is the y. How do you find the hypotenuse?
The Pythagorean theorem.
Pythagorean theorem. Yes, this is 13. The hypotenuse is always positive. Always, always, always. You don't have to worry about plus or minus, but the side lengths, you do have to get correct. Like you have to say, okay, is it really when I go to the right that it's positive, and when I go down it's negative, and it is. So from here, you just have to write the 6 trigonometric functions. We talked about how to do that last time. I'd recommend starting with sine, then going to cosine, then tangent, and then we'll get the other one. So can you tell me the sine of that angle?
The sine would be negative 12 over 13.
Yes. You could learn it as y over x, opposite over hypotenuse. That's all good. How about cosine?
It would be 5 over 13.
Good. And then tangent?
That would be negative 12 over 5.
Really good. Okay. Cosecant of theta, secant of theta, and cotangent of theta, they are all related to the one on the left. That's why the order really matters, so you can kind of pattern it. So cosecant is the reciprocal of sine. So you might think to write 13 over minus 12, but that minus really needs to come up top. Minus 13 over 12. Secant is the reciprocal, 13 over 5. And then cotangent, 5 over minus 12, you're flipping, or minus 5 over 12. Any questions on that?
No.
Okay. All right, well, we will move on to 6. All right, so notice the angle given is in the first quadrant. So I would sort of come over to the right, separate the drawing. This is the angle. 3, 1. Does that mean which is 3 and which is 1 on this triangle here?
1, that should be, so x and y. So 1 should be opposite.
Okay, so yeah, so you I like the way you said it first time. X is 3. Think of x as horizontal, y as the vertical. Okay, now this time when you want to find the hypotenuse, like you said before, it's a squared plus b squared equals c squared. It's 3 squared plus 1 squared equals c squared. 9 plus 1 equals c squared. This is not a perfect square, but you can still write it as a square root of 10. Is that okay?
Yes. So you would never, so you just keep it as a radical always.
Yes. Yes. Now let's just say it was like something like the square root of 12, which reduces. You would want to reduce that.
Okay.
Okay, so now from sine theta, we'll start with sine theta. Sine theta is 1 over the square root of 10. And what is the problem with what is written here?
You need to rationalize it.
Yes, yes. And you know, it's not apparent why, but that is what is required. So it multiply the top and bottom by the square root of 10. So you get square root of 10 over 10.
So you just leave it as square root
Yeah.
of 10 over 10.
When the square root's on the top, you're okay. It's just when it's on the bottom that it's not okay.
Yeah. Okay.
All right, cosine theta is the adjacent over hypotenuse, so kind of same issue, 3 over the square root of 10. Okay, will you rationalize this one for us and let me know what you come up with?
So you would get 3 radical 10 over 10.
That's right. 3 square root 10 over 10. Tangent of theta, I know it's a little bit, I got to scroll up a little bit, but it's opposite over adjacent, or y over x. So it ends up being 1/3. Now we need cosecant of theta, secant of theta, cotangent of theta. So cosecant is the reciprocal of sine, and we actually can go to 2 places. We can either go to the final answer or any of the intermediate answers. And I would actually go back to the original, because when you flip it, it becomes the square root of 10 over 1. You go back to this one over here on the left. Rather than, if you were to write 10 over square root of 10 for the second one, you then have to rationalize it.
Yeah.
Now, it does work out exactly the same, and I'll show you that here. It's just introducing extra work. Okay, so you end up getting 10 square root 10 over 10, and then the 10s cancel and you get square root of 10, which is the same. So it's up to you. Like, it's not wrong to do it the way we did on the right here. It's just that you can save yourself a little bit of time on occasion. So the same thing applies here to the secant. You could use the square root of 10 over 3 and be done. Or you can do 10 over 3 square root 10. You do have to rationalize. You have to multiply the top and bottom by the square root of 10. And so that equals 10 square root 10 over 30, which ends up being square root of 10 over 3.
Yeah.
Last one, cotangent theta is 3 over 1.
Yeah.
So you're going to get a problem like this in a test or quiz. You have to be able to get all 3 sides of the triangle, write them all out, rationalize if needed.
Okay.
All right, so before we do number 9, I want to ask you about the unit circle. I'm going to drop a link in the chat here again. If you already have it, you know, just the same one. There's a unit circle on page 3. It's kind of an overwhelming thing for most students. You are expected to know this in this course. Now, whether your teacher enforces that or not, you know, that's a different thing. Have you seen this before in class or in your textbook?
Yes, we have a copy too.
Okay, that's great. Now, here's an important question: is will you be allowed to use it on the test or quiz?
We will.
Oh, that's great. That is fantastic.
He said next year though, like when we're in like actual pre-calc, we aren't allowed to.
And that is a good thing to know, because it, like, seeing it for the first time and then being expected to know it is really, really tough.
Yeah.
Okay, do you have one out now? Do you have one with you?
Yes, I do.
Okay, fantastic. So we're gonna look at number 9. As soon as I get number 9. Okay, so 9, it says theta equals 0. It says the angle is 0. So on the unit circle, it's literally this spot right there. Okay, where x is 1 and y is 0. So it's not a triangle because it's on the axis. It's just an x and a y value.
Right.
And that is enough to be able to do what we need to do here. Okay, so the sine of theta is the x value. In fact, on the unit circle is somewhere, your unit circle should say that x, I'm sorry, this is wrong. I apologize. Oh, that's bad. X is the cosine value, y is the sine value. And it should say that somewhere on your unit circle. So the sine of theta is the y value, which is 0. Cosine of theta is 1. And this is where this could be a little bit something new here. So tangent of theta is sine theta over cosine theta. That there's a couple of different ways that this can be written. This is a new one. So instead of it being y over x, which is true, you can also think of it as sine over cosine, which is 0 over 1. It still is y over x. This reduces to 0.
Yeah. So if the 0 is on the bottom, it's undefined, but if it's on the top, it's 0.
Yes, and we're about to see that here with cosecant theta, because you can really think of like an intermediate thing here is that with sine, it's really like 0 over 1. So when you flip it, it's 1 over 0, which is undefined.
Right.
But that's not the same for cosine. Cosine, you can think of it as 1 over 1. When you flip it to get secant, it's just 1. That's okay.
Yeah.
But tangent, unfortunately, is cotangent of theta. If you think of tangent as like 0 over 1, cotangent is now 1 over 0, and that's also undefined.
Right. Okay.
So I think we've got another one in this grouping, maybe. I hope we do. 10. Okay, good. 10. All right. All right, so 10 theta equals 540 degrees. And if you look really hard at your unit circle, you'll recognize that 540 degrees is not on your unit circle. And it's like, well, I thought everything was on there and that it's supposed to have all the information. It kind of does, but it's not exactly there. So if you go all the way around the unit circle, how many degrees is that?
It's 360.
360, just like in a circle. So there's what's called a coterminal angle, which you don't need to know, I'm guessing, in this class. But you need to know that if you go all the way around, that's 360. And if you go another 90, that's really 450. And then another 90 again gets you to 540. So 540 is going all the way around. And typically it's shown like this, where it's a little spiral. It's like, all right, I went all the way around. That's 360. That's another 90. That's 450. And then another 90 is 540.
Okay.
Is that okay?
Yes.
Okay, so in terms of the unit circle, that's right over here. It's right over here. So it's where x is -1, x is -1, and y is 0. And you can see that on your unit circle, see it on the one I put up. Is that okay? Clear?
Yes.
So you have to figure out, like, where are you on the unit circle? Like, basically it's like you, in these problems, you could be at any one of these positions all the way around it. You got to know where you're at. Right now from here, sorry, I just need to start with sine theta. Sine theta is the y value. Cosine theta is the x value. Tangent of theta is y over x, y over x. What would that be in this case?
It would be 0 over -1.
Good, and that ends up being 0. So I'd like you to find cosecant theta, secant theta, and cotangent theta for me for the this one here.
So cosecant would be 1 over 0, which is undefined.
Okay.
And
Well,
then secant is -1. And then cotangent is -1 over 0, which is
okay, what
undefined.
undefined? Yeah, you can't just leave it like -1 over 0 because the instructor won't be able to interpret that for an answer. So good, really good. We really should do one where it's on the unit circle, but we're kind of we're gonna do that in 25 through 32. So I guess that makes up for it. Any questions on this before we move on to the next set of problems?
Nope, I'm good on that.
Okay. All right. So let's I'm going to do these out of order to try to make more sense of this. I'm going to start with 27. Sine of -150 degrees. Okay. So another thing you'll notice about your unit circle is that it does not have negative angles. They're positive, and positive go counterclockwise, negative go clockwise. You know, I don't make those rules. That's just the way it is. So you might think to yourself, well, okay, 150 is there, but -150 is going the other direction. Okay, so -150, you're starting here at the 0 again. This is 90 to get down here. 180 gets you to the horizontal. So -150 is right there.
Yes.
Okay, and are you comfortable kind of navigating this?
Yeah, it gets so confusing sometimes, but I think for the most part, it's good.
So degrees are better than radians. Looks like we've got some radian problems that we'll do in a bit. So sine is the y value. Y value. So you just go right there and you just have to read off the y value.
Yeah.
What is the y value at this place?
The y value is 6.
So this is the ordered pair here. -√3/2, -1/2.
Oh, sorry, I was looking at the thing above it. -1/2.
-1/2, yes. Okay. There's a lot that goes into getting the answer, and the answer is very trivial. It's like a very basic thing, but you have to know how to get there on the unit circle and then be able to read the point.
Right.
So we actually have some time here. I'd like to just detour a little bit more into this topic here with you, because this is really important. Can you tell me the sine of 120 degrees?
120.
Yes, the sine of 120 degrees. Basically, I'm asking, what is the y value at 120 degrees?
It is radical 3/2.
Very good. How about the sine of minus 30 degrees?
Oh, the negatives always confuse me.
Okay, so if it were positive 30, you'd go up that direction, right?
Uh-huh.
See that? So negative just means you're going the other way.
Okay, so it's basically just like the opposite end of whatever degree you're looking at.
It does kind of work out that way. Now we'll do a few others. What's the y value there?
It's -1/2.
Negative 1/2. Good. Okay. How about the sine of negative 240 degrees? Okay. So notice the positive one would be there.
Right.
So using kind of what I hear kind of is that you want to basically go up to that one there.
Yeah, so radical 3/2.
Yes. Okay. Very good. All right. Now let's do a couple of radian ones here. What is the cosine now? So cosine is the x value. The cosine of 7 pi over 6.
Sorry, say that again. My volume thing went down.
The cosine of 7 pi over 6.
7 pi over 6. Oh. So it would be negative radical 3/2.
Good. Now, how about the cosine of minus pi over 4?
Pi over 4. That would be radical 2/2.
Yes. Very good. Okay, so let's jump back to your problems here. We're going to do 31 next. We'll talk about how to do the others, of course. All right, so 7 pi over 4, you hope it's on the unit circle. You hope like, all right, is that on the unit circle? Is 7 pi over 4 on the unit circle?
Yes.
Okay, now cosine is the x or the y value.
The x.
So what is the x value there?
It is radical 2/2.
Good. Yeah. Now in pre-calc, the other courses, there are other ways to do this where you don't just look it up on the unit circle. We're kind of omitting that, but that is it's something you might see. Okay, let me know when you're ready for us to move on to 25.
Okay, I'm ready.
All right, so 25 here, secant of 135. So when you go to your unit circle, 135 degrees right there, x is cosine, y is sine, okay? But you want secant. So you have to know what secant is in terms of sine and cosine. It ends up being 1 over cosine 135 degrees. So you need to find the value of cosine at 135 degrees and write it in the denominator. So everything on the unit circle goes back to sine and cosine. Can you tell me what the value of cosine of 135 is?
Yes. 135. It would be -1/2.
So we're talking about right here.
Oh. Oh, I was looking at the one right above it. I was like, I don't know why I said that. Negative radical 2/2.
All right, so now this one's really bad, really, really bad. So you're expected to simplify this. Okay, so the first thing to do is to multiply the top and bottom by the reciprocal. And you'll find most of the work is actually from this point forward. So it's 2 over negative square root of 2 because everything on the bottom cancels. Now up top, the negative goes to the numerator. And from here you have to rationalize.
Yeah,
So it's almost more work to do everything from here than to just look it up on the table.
right.
So the 2 square root of 2 times square root of 2 on the bottom becomes 2. You divide, becomes negative square root of 2.
Yeah.
Any questions on that before we do another one?
No, I'm just finishing writing that one down.
All right.
Okay.
All right, so let's look at 32. It's another secant or secant. All right, you want to first figure out is 11 pi over 6 on the unit circle, because this is really 1 over the cosine of 11 pi over 6.
So 11 pi over 6.
Yes, is that on the
So
unit circle?
yes, so it would be radical 3 over 2.
So this is 1 over radical 3 over 2. So from here you have to simplify the fraction within the fraction by multiplying by the reciprocal and then rationalizing. Would you give that a shot here and see if you have any issues with that?
So you multiply it by radical 3.
I would first multiply by the reciprocal
Okay.
to get rid of the.
I just always get confused with the rationalizing.
That comes next. So you're going to rationalize. You're going to rationalize from here. So that this just clears out the fraction on the bottom.
Yeah. So then that'd just be 2 radical 3 over 3.
Yes. Okay, any questions on that before we move on?
Nope.
All right, we're going to do 28 next. 28 is a cosecant. So cosecant is really 1 over sine of minus 420 degrees.
So that would be,
So notice if you went all the way around the unit circle in the negative direction, that's uncomfortable, but if you go all the way around, that's negative 360. And then you have to go a little bit further, another 60. Okay, now if you don't like that, we talked about, well, if you go the other way, if you go all the way around, that's 360. And then you go to 60 right there. But you have to remember to drop down to the other side. Either of those stand out to you?
So I think it would be 300 degrees or 315,
Yeah.
no, 300 degrees.
300, it's the X or the Y value there. Which one?
So that would be the Y value. So radical 3/2, but it's negative.
Yes. Okay, so will you try rational or simplifying and then rationalizing this?
Yes. So 2 over radical negative or negative radical 3.
Okay.
Then you have to rationalize that. So it'd be 2 radical negative 2 radical 3/3.
Yes. So you multiply top and bottom by radical 3. And then you need to bring the negative up at some point.
Yeah.
All right. So that's I think that's good. The next ones we're going to do are tangent and cotangent. So we'll start with 26 for tangent. All right, so the hard part about tangent is that you have to do more manipulation. So you're gonna first go to 240 on your unit circle, and in the numerator you're gonna put the y value, and in the denominator the x value. Okay, so I want you to go to 240 in the unit circle there. Tell me the y value. Tell me the x value, please.
So the x value is -1/2, and then the y value is negative radical 3/2.
Yeah. Now make sure you get these in the right order. That's if you mix them up, completely wrong. Okay, so from here you want to multiply the top and bottom by the reciprocal. Like that.
Yeah.
Now on the bottom, everything cancels. Okay. On the top, the -2 goes with the negative, so it becomes 2 squared 3/2. Is that okay?
Yes.
We're not done because the 2's cancel. So this becomes just the square root of 3.
Right. Okay.
Any questions on that before we go to 29?
No, I don't think so.
Okay. So 29, tangent. Just like the previous problem, you got to get a y and you got to get an x value. So I'll take them in either order, but just tell me which one it is. Go to -3π/4, or if you like you've been doing, go to 3π/4 and drop up or down depending on which one it is. Give me the x and the y value there.
So So negative 3 pi over 4, that's when you have to go down to the opposite one, right?
That's right. So if you like that approach, you go to 3 pi over 4, and then you drop straight down to that one, 5 pi over 4.
So that would be, so the x value is negative radical 2 over 2, and the
Okay.
y is the same thing.
Yeah, now that's very important when you're simplifying here. What is the same thing on the top divided by the bottom? What does that reduce to?
Isn't that just 1?
Yes. So I believe the only one we have not done yet is 30. All right, so cotangent is the reciprocal of tangent. Couple of ways to do this. You can do 1 over the value of tangent, or because tangent is y over x, you can switch that all together. But we'll just do it in pieces here. That negative is really upsetting because it's like going the wrong way. So you got to figure out, well, where is 8 pi over 3? So if you go all the way around the unit circle, that's 2 pi. Do you see that on your unit circle if you go all the way around?
Yes.
Okay, so now it's like, well, how much is left over? It's 8 pi over 3 minus 2 pi. That tells you how much is left over, how much you have to keep going. How do you subtract these two?
Do you just keep the pi there, so like it'd be 6 pi?
You have to make a common denominator.
Oh, for 3.
Yeah, and it's one of those things where if you haven't done it in a while, you're like, oh yeah, I forgot about that. So it ends up being 8 pi over 3 minus 6 pi over 3, which is 2 pi over 3. And that tells you where to go, because you got to go another 2 pi over 3 in your unit circle, which gets you to kind of about there. But you don't want positive, you want negative. So that means you have to drop down to, instead of doing it at 2 pi over 3, you drop down to 4 pi over 3. Is that what about that is unclear or needs to be further explained?
No, I think I understand that one.
Okay, so this is 1 over y over x, or you can flip it all together and just make this x over y. Doesn't matter. What would you prefer for the tangent?
Just maybe x over y.
Okay, so what is the x value? What is the x value here? At
Yes.
x value at that place in the unit circle.
Yeah, so it would be negative 1/2, is that right? Yeah.
That's right, over.
And then over radical 3 over 2.
A negative radical 3 over 2.
Oh, yes.
Okay, now this time we're going to multiply the top and bottom by the reciprocal. 2 over negative square root of 3. 2 over negative square root of 3. All right, so in the bottom, everything cancels. In the top, it becomes the 2's cancels and the negatives cancel, so it's 1 over the square root of 3. From here, you can multiply the top and bottom by root 3.
So then, is that just your answer?
That is it. That's your final answer.
Okay.
All
Okay.
right, so with the time left, I think we should do a few more of these and just incrementally build into this. So whenever you're ready here, just get a fresh blank piece of paper. We'll do a couple.
Okay.
All right, what is the sine of pi over 6?
Pi over 6. That would be 1/2.
1/2. So what is this cosecant of pi over 6? How are they related?
So cosecant would be the reciprocal of that.
Right, now if you didn't know that or didn't have it, you might write sine 1 over sine pi over 6,
Yeah.
which is 1 over 1/2, which is 2, like you just said.
Yeah.
All right, so if you think you've got that down, give me the secant of 2 pi over 3.
2 pi over 3. So that would be -2.
Yes, -2, very good. Okay. All right, so let's increase the difficulty a little bit. What is the tangent of 4 pi over 3?
Um Wait, I know the tangent's always positive in this quadrant.
It is.
But
It isn't. So just you got to do the y over the x,
okay.
and it does work out. That's a good check though. It's like, wait, did it actually work the way I think it should? Yeah.
So you would do negative radical 3 over 2 over, or you can do multiplied by 2 over -2 over 1.
What goes on the bottom? Sorry, just making sure.
Negative 1/2.
Good. Okay, go ahead and reduce that.
So that'd be radical 3.
What did it say it one more time?
Radical 3.
Yes. Yes. Very good. All right. Let's do a few more here. Let's do the cotangent of 7 pi over 4.
So 7 pi over 4 is radical 2 over 2, which is the x. So that would be on the bottom. Or actually, no, it would be on the top.
That's right. Yeah, it's x or y. Give me your final answer here.
Oh, it would just be 1. -1.
Yes. Okay, so now let's just do a couple of negative ones here. Let's go sine -7 pi over 6.
Sine -7 pi 6. So that would be, the x would be radical 3 over 2. Oh, okay, so then 1/2.
So what is your answer?
1/2.
Yes. Okay, very good. Cosine -135 degrees.
So negative 135 would be negative 2 over radical 2 over 2.
Yes. Very good. Okay. We are going to stop here for today. Good job.